In section 1.7, we're talking about inverse functions, and these must pass the vertical line test once you have found the inverse. So you have to keep that in mind for later in the section. So if you have a normal function, f of x equals y, then it has the ordered pair point x, y. So when you talk about its inverse, it's the f inverse of y is equal to x. So your ordered pair points are going to switch locations. So x's become y's become x's. So if you had to graph these two on the same plane, so if you had f and f inverse, they are symmetric with respect to the line y equals x. This is a question on your homework, and that is the answer, y equals x. So when you reflect these, it reflects across the line y equals x for a function and its inverse. So, for example, what this means is if I have f of 2 is equal to 4, that means that this ordered pair point is 2, 4, and this is on the original f function. So, if you want to find f inverse of 4, then that's going to be the ordered pair point 4, 2, because this is the inverse, so that x and y switch places. So, if I have f inverse of negative 2 is equal to negative 7, that means that this ordered pair point is negative 2, negative 7. So if you want f of negative 7, that's going to give you the y value of negative 2. Because again, these ordered pair points are just switching. X becomes y becomes x. So for the last one, you have f of negative 8 is equal to positive 8. So that ordered pair point in the original is negative 8, 8. And then if you wanted to do f inverse of 8, it would, of course, be negative 8 because, again, you are having the x becomes y and y becomes x. Now, there is a question on your homework that indicates that you want to find f of negative 8 raised to the negative first power. Now, notice every single one of these has f inverse right after the f. Now, this one is outside, so this is not f inverse, okay? What this means is that if we do f of negative 8, okay, that's going to be this 8 right here, and then you take 8 and you raise it to the negative first power, which is 1 over 8. So the placement of the negative 1 is very important. So a different version of the same questions look like this. So this indicates that I have x values in my domain, f of x is given, and the first thing it wants to know is f of 8. So I look for the 8, and f of 8 would be the number 5. Then I go f of x is equal to 7, so what that means is that when y is equal to 7, then x is equal to 3. All right, if I'm doing f inverse of 5, that means that I'm looking for a y value of 5, which would take me back down to here. Then that would be equal to 8, because that ordered pair point, of course, is inverted. So this one is 8, 5. This one would give me 5, 8. All right, and then if I have f inverse of f inverse of x is equal to 3, that means that I'm looking when this is 3, then my x value would be 7, because the ordered pair point would be 7, 3, and what they want is this x value. This is a different format that they can ask you the same kinds of questions. So as I look at this graph, I have ordered pair points here at 0, 4, and here at 3, 0. So these are on the original graph. So if I'm looking at f of 0, that means when x is equal to 0, y would be equal to 4. The next one says f of x is equal to y. So when y is equal to 0, then x would be equal to 3. So now I'm looking at the inverse. So to look at the inverse, I am taking these ordered pair points and I am changing them into 4, 0 and 0, 3, because x becomes y and y becomes x. All right, so that would be the graph of the inverse function. So if f inverse of 0 is what I'm looking for, then that answer is going to be the number 3. Because this ordered pair point is 0, 3. And this is on f inverse of x. All right, and then f inverse of 0 means that if I'm looking on my inverse function, when the y value is 0, then x would be equal to 4. Those can get confusing, so slow down when you're doing those. Another thing that they're going to ask you to do is actually come up with an equation for your inverses. So the first thing you do is to write f of x as y equals, and then every x becomes a y and every y becomes an x, and then you take that new equation that you have created and you solve it for y, and then you write y equals as f inverse of x equals. So we're going to do a couple examples of this. So the first thing I'm going to do here, that's my original, and I'm going to change this into y equals. All right, so then y becomes x and x becomes y. And now I need to solve this for y. So I'm going to add y to the other side and subtract x to the other side. So f inverse of x is equal to 8 minus x. And it's very rare, but occasionally you'll get the exact same thing as its inverse. That doesn't happen very often, so don't think that. But just pay attention to your solving. All right, these can get a little more complicated. This is not one that is. All right, this is just another idea of, okay, how do I start this? So you change f of x into y becomes x, and x becomes y, and then we're going to solve for y. So I have x minus 5 is equal to 11y, so that y equals x minus 5 in my numerator, and I divide that by 11. So that would be my inverse function. Now, the things that make this more complicated, for example, is if I have a fraction. So again, first thing I do, f of x is going to turn into y. And then I change y's to x's and x's to y's. And on this one, when I solve, I have to slow down just a little bit. I'm going to put a parenthesis around my denominator, and I'm going to multiply it up to the other side. So I have x times y plus 8, and that's going to be equal to 1. I have to distribute the x. I have xy plus 8x is equal to 1. And at this stage, I'm trying to get y by itself. So I'm going to keep xy where it is. I'm going to subtract 8x. And I have one more step to get y by itself, and that's to divide by x. So that I have y equals, which I'm going to write as f inverse of x equals. So y equals 1 minus 8x over x. There is no other simplification you can do. Okay, these can get a little more complicated. Again, you still do the exact same steps. So f of x is going to be changed into y equals. Then I change y's to x's and x's to y's. And now I have to solve for y. So I have to isolate that y by subtracting 7 first. And then I still have the cube root of y. Well, to get rid of a cube root, you have to take both sides and raise it to the third power. You do not have to multiply the left-hand side out. You leave it just like this. And then this cube is canceling out not only the cube root, but also the radical. So this is y equals. And this would be f inverse of x. So you'd have the quantity x minus 7 to the third power. And that would be my inverse function. This last one on this page is one of the most difficult, only because you have more variables to deal with. The process still stays the same. You're going to first change f of x into y equals. Y becomes x, and all of your x's become y. And at this stage, sometimes we don't really notice this, but I'm going to pull it out right now so that it doesn't become an issue. Everything on the right-hand side is negative. So if I factored out a -1, I have 2y plus 4. And on the bottom, if I factor out a 1, I have 3y plus 5. And then those -1s will cancel out. And that way you're not fighting with the negative signs. You don't have to do that. It's still going to work out fine. It's just that sometimes we get lost in those negative signs. So if everything is negative, or at minimum, if these first two are negative, you might want to factor it out and then work with what's left. Excuse me. So you're now going to take that denominator and pull it up. So I have x times that denominator, 3y plus 5. And on the other side, I still have 2y plus 4. I have to distribute this x to both of these. So I have 3xy plus 5x is equal to 2y plus 4. And remember that our goal is to solve for y, so I need to get the terms together on one side that have y in them. So 3xy is going to stay. I'm going to subtract 2y over here. So my y's are together. So now I need to move the 5x term to the right side. So that's going to give me negative 5x plus 4. And now that I have the y's together, I can factor the y out. So that leaves me with 3x minus 2. And that's going to be equal to negative 5x plus 4. And at this stage, my last step is to divide both sides by 3x minus 2. So that's going to give me y equals, which I'm going to write as f inverse of x, is equal to negative 5x plus 4. And I'm going to divide that by 3x minus 2. And that would be my inverse. So I've done another one of those here. I've done a couple of these here because these are the ones that tend to give kids the hardest time. So if you don't need these examples and you understand it, feel free to skip over these. If you need a little bit more assistance on these, please watch them and pay attention to what we're doing. So the first thing I do is change f of x into y, and then my y become x and my x become y. The other thing I'm going to warn you and caution you on with these is make sure that your handwriting is legible, because if you can't read it, I'm not going to be able to read it either. And if you confuse your x's and y's, this becomes a little difficult. So as we multiply the denominator up to the left side, and then distribute your x. So you have 6xy minus 3x, and that leaves me with 2y plus 4 over here. And again, I want to collect the y terms to one side. So I subtract 2y here, and then that negative 3x has to go to the right side, so I add it. And then I can factor out my y because I now have the terms in common. So I have 6x minus 2 is left after I factor. And I didn't leave myself enough room, so you keep going down the page. So here I'm going to have f inverse of x is equal to 3x plus 4 in my numerator. And then in the denominator, we're going to divide by the 6x minus 2. And that would be my inverse function. All right, another type of question they'll give you is something that looks like this. So I have the function, and they are asking me not to find the inverse, but they're asking me to find the inverse at a particular value. So you can do this two different ways, okay? So I know that negative 4 is what y would be equal to in the original function, because remember again, this gives me the ordered pair point yx. So for me, that's saying that negative 4, and then I'm trying to come up with the x value. So I can plug a negative 4 in right here and solve. Or the alternative, okay, I'm not going to do it both ways, but the alternative is to find the inverse of this, figure out what f inverse is equal to by doing the process that we just did, and then you substitute the negative 4 in everywhere you see an x. So I'm going to do only one way. So I'm going to use negative 4 is equal to x plus 1 over x plus 7. And I'm going to solve for x. So again, multiplying up, the bottom comes to the left-hand side. I have negative 4x minus 28 is equal to x plus 1. And now I'm just solving for x. So subtract the x over, I get negative 5x. And if I add 28 to 1, I get 29. So x would be equal to negative 29/5. Now, for those that want to do it the other way, you have to go through and find your inverse. You don't need to do it both ways. I'll show you both ways. You pick which way you want to do it. So I'm going to have y is equal to x plus 1 over x plus 7. X becomes y becomes x. Multiply up, so I get x times y plus 7 is equal to y plus 1. So xy plus 7x is equal to y plus 1. Collect your y terms to one side so that you can factor. And 7x has to go to the other side by subtracting. We factor out the y, so we have x minus 1. And that's still equal to negative 7x plus 1. So f inverse of x is equal to negative 7x plus 1 over x minus 1. And at this stage, what you do is to find f inverse of negative 4, you do f inverse of negative 4. So you plug that in. So you have negative 7 times negative 4 plus 1. And then you have negative 4 minus 1. So this gives me negative 28 plus 1. 28 plus 1 is 29. And then negative 4 minus 1 is negative 5. So you're getting the exact same answer, whichever way you want to do it. Just be careful not to get them confused. The next question wants you to find the domain on which f is 1 to 1, which means it has to pass the vertical line test and the horizontal line test, and non-decreasing. All right, non-decreasing means that it is going to be increasing from left to right. So as I look at this graph, I know that it is a parabola. I know that by adding 2, I have moved 2 to the left. All right, so we have this, and then we would go here and here. Now, if I drew that entire thing, then I do not pass the horizontal line test. So that would mean that it is not 1 to 1. All right, so if I think about this, as I do that, that's decreasing, okay? So that is not part of my graph. So if I look at it going this way, then that is non-decreasing. And if I eliminate the part that I'm saying is decreasing, then this now is 1 to 1 because it passes the vertical and horizontal line test, and it's non-decreasing. So the domain that works on, reading left to right, would be from negative 2 to infinity. All right, so find the inverse of x restricted to this domain. So I have y is equal to x plus 2 quantity squared. Change your y's to x's and x's to y's. And now we need to solve for y. To get rid of a square, we have to take the square root of both sides. So this is plus and minus. And then this would leave me with y plus 2 over here. So then y is equal to negative 2 plus or minus the square root of x. Now, the plus and minus create the top and bottom. So we don't need both, okay? So I'm going to go back up to this graph, and I want to talk about what happens when I try to graph this thing, all right? So we have the ordered pair point, negative 2, 0. So mine will be 0, negative 2, all right? The other point I have is negative 1, 1. So if I go 1, negative 1, then this is telling me that my graph for my inverse goes this way. So what that indicates to me is that when I'm looking at these, I don't need both of those. I only need the positive one. So the inverse that's restricted to this domain is y is equal to negative 2 plus the square root of x. And that would be the inverse restricted to that domain. The last little piece of this section says that two inverses, f and g, are in fact, two functions, f and g, are inverses if when you do their compositions both ways, you end up with x. All right, so if something says, are these inverses, you can't just randomly guess and say, sure, I think they are. You have to actually show me. So we are going to go through and do both of these compositions. So we have f of g of x, so g of x is x minus 4. And then I'm going to plug that in to the f function where this x is. So that means I have x minus 4 is what I'm substituting in. And then I still have that plus 4 on the end. So those cancel, and I have an x. So we're halfway there. The rest of it, you have to do the composition in the opposite direction. So you have g of x plus 4. So I'm plugging x plus 4 in over here into the g function. So I have x plus 4, and then I'm going to subtract 4. So again, the 4's cancel, so I have an x. Because both of those give me an x, you can say that f and g are inverses of each other. Thus, g of x is called an inverse of f of x.